All right, I know this is kind of awkward for us because we have this giant screen here, but please let me know if like what I'm saying is not here. Today we are going to start with alkanes. My goal would be to hit on alkanes. We have a worksheet to go through. Hopefully we'll do a little break in between because I do have a 5-minute break planned at 12:50. And then we will get started on 1.3 dimensional analysis, and I have another worksheet. If you are online, those worksheets are provided in modules, and I have the keys also posted. I just want to reiterate what we discussed last class. When we're doing worksheets, it's not always about getting the right answer because you're not turning anything in to me as a grade. So our goal is just to practice over and over and over just to get you more comfortable. And those answers are going to be very helpful if, let's say, I'm not here in front of you and I'm not here to help you guide to the right answer. You have that as a way to be like, okay, am I on the right track? So use those answers to help you if you're stuck, but don't think that you need to turn something in to me today and you just put the right answers and that's it. So we're going to try to make sure that we're getting everything each and every time. And that's what those worksheets are for. I do the worksheets every single time we have a class. I absolutely love it. Same with your homework. I think homework's a lot of fun just because I'm biased. I love chemistry. But I've discovered that chemistry is all about just keeping practice. I'm working with Achieve right now. I am aware that in Canvas, you don't have access to the homework quite yet. But if you go through the module and click on Achieve and get your site connected to our Canvas site, you can see we do have 2 current homeworks open if you'd like to get started. I'm trying to work with Achieve to get it to connect with Canvas, but I'm not having much luck right now. But I will keep you updated. I've been calling them every single day, actually. So they do have 2 homeworks open. I do want to point out, nothing is going to be due until right before we have the exam. So if our exam is Friday, June 13th at noon, everything is going to close at 11:59. I'm not doing that to encourage you to do it all right before the exam. It would definitely help you study for the exam, don't get me wrong. I think everything that I assign you is going to be practice for the exam. But I just don't want to stress you out by having you do it right before. So please do things in a timely manner so you're not stressed out before that exam. So I'm trying to not do that, but I want to be kind to those who have jobs, who have other classes that are a little bit more overwhelming. So this class will give you a little bit more time to get those things done. Are there any questions before we get started? So alkanes. Before we get started, let's talk about some questions to ponder. Last class, we talked a lot about combustion. We had a lot of keywords, so I want to ask you, what are some common fuels used for combustion? What are the most popular ones that you can think of?
Yeah.
Gas, yes, gasoline.
Propane.
Say it again. Propane, that's a very popular one if you like to grill and barbecue. We use propane tanks. That is definitely a fuel. Methane, that's natural gas. Let me make sure I'm not a good speller. Propane, methane. Yeah, so methane is a natural gas that we use in labs, but also it comes out at stinky smell. That's gonna be that methane. Anything else?
Butane.
Butane. We use butane in lighters, and I know like if you like to cook, they have butane torches, but most commonly it's going to be used in lighters. So butane. So even if we haven't gone very far into chemistry, you've already used chemistry in your everyday lives. You've already done combustion reactions. If you take a lighter and light that flame, you are taking butane mixed with oxygen with a little bit of starch, and it's producing carbon dioxide and water in gas form. You've already done that. You've already made those combustion reactions. I will point out there is a lot of familiarity between these ones. And then what's in gas is ethanol. They have ethanol in gas. So the F part of that, I want to just point that out as something that's also in common between all of them. So we're going to get into alkanes. So compounds, alkanes are compounds made of carbons and hydrogens in any particular pattern. So y'all all said methane, propane, and butane. So in the bottom, I have what they look like. Typically, what we did last class was we had the microscopic with those circles. This is just a more simple version of that. Instead of me drawing circles and putting a C in front of it, I'm just putting a C and an H, but you can also think of it microscopically. I don't have my dot camera up, but I have these little things, it's the same concept. I'll put the dot camera up later. Carbons and hydrogens, are they non-metals or metals? Non-metals. If you don't have your periodic table of elements with you, come and grab one, I have them up here. Please just always bring it with you to class. Just because it's not gonna be memorized just yet, but it's gonna be very helpful to have that in front of you while I ask you those questions. So carbons and hydrogens are on the non-metal side. I know hydrogen is on column 1, so I'll point it out again. It acts like a column 1 but it's not a metal, so it is a non-metal. Because they're both non-metals, they're going to have covalent bonding between them. So that's gonna be something that's in common between all of them. And I do want to point out that each of these lines represent a shared pair of electrons that creates the covalent bonds. That's something that we might get into more depth later, but you will definitely hit that in Gen Chem 1. You'll go into the electrons and things like that. But that's how these bonds are formed. So hydrogen has an electron, carbon has an electron, and then they share it to create a single bond. Okay. Can anyone tell me if they notice a pattern between methane all the way to butane?
Yeah, the same chemicals.
They have the same chemicals, absolutely. What about going from methane to propane to butane?
The number of hydrogen atoms is 2 times the number of carbon atoms plus 2.
Yeah, so it's getting bigger. There's more carbon atoms and there's more hydrogen atoms as we go through. You might hear me use the term chains because to me it looks like a chain. So if I have methane with 1 carbon and I add another carbon to it, I have something else and add another carbon, it's kind of like you're making a long chain. So that's gonna be definitely what is in common between all of them is I am adding carbons and I'm adding hydrogens, and definitely the name will change to reflect that. All right, let's talk about some other things. It's not always gonna be a chain here. I just wanna point out, this is what we call an organic molecule. It's called aniline. You're gonna see these types of structures, especially when you hit, I guess, organic chemistry. Definitely you'll see a little bit in Gen Chem both. So this is like a line drawing where, like I mentioned before, instead of me putting those big circles in there, I'm just putting it with the elements. They're all covalently bonding because even though I switched out, sorry, it's over here. You said nitrogen, that is also a non-metal. So even though it's a different molecule in there, it's still all non-metals, all covalent bonds. They all share those electrons. So nitrogen over right here, let's put it out here, has an extra pair of lone pairs that nothing is there to bond to. So that's why you have those 2 little dots. It's a little different, but if there's nothing bonded to it and it has that extra pair, we'll put those in. So this is what we call a Lewis structure because it is the structure of the compound. And can anyone tell me what this is?
Double bond.
That is a double bond, yes. If I was to put a third line. Triple bond. So you might see that too if I was to do these line structures. So double bonds will share more than a shared pair of electrons, they'll share 2 pairs of electrons. And a triple bond will share 3 pairs of electrons between them. So carbon, I want to point this out. Carbon is very selfish. It always wants to be bonded to something. You'll hit that a lot when you get further on in chemistry. But carbon wants to have 4 bonds. So if I was to point out this carbon right here, those double bonds count as 2 because it's 2 bonds, 2 shared pairs of electrons, and then it has 1 bond to hydrogen, and it has another bond to another carbon. So it has 4 bonds. Carbon's always going to want to have 4 bonds. Hydrogen is also in that same belt, but it cannot do more than 1. Hydrogen will always have 1 bond. It can't have a double, it can't have a triple, it doesn't have the amount of electrons. So you'll kind of see that trend as we go through this. And then nitrogen's a little tricky because it can do multiples, it can do doubles, it could do triple bonds, it can do lone pairs, but it typically will have 3 bonds. And lone pairs can count as something, but it's just nitrogen wants to have those 3 bonds. And we already talked about that last part where I said, what do 2 and 3 lines? I don't like this. I wanna talk to y'all. Let me get up my, my little doc here real quick. Ugh. This is a brand new classroom I'm still getting used to. Alright, so we are gonna be hitting on what we call VESPER. What's wrong with this doc cam? I want like, there we go. Got it. So on the screen, if you are online, you have the methane, the ethane, and the butane in their structures. Underneath, you'll see them kind of written in a very similar way, but those are just meant to kind of show you a more 3D route. But I need to get it up on this camera. It's hard going between two computers. All right. Okay, so everyone's online. You can kind of see the dot cam if you look at my box in Zoom. So here is ethane. Let me see if I have it right. Oh. That's light. It's light. Is that bright enough for you? Okay. So ethane here has those two carbons. Remember that black typically will represent carbon because carbon, of course, is like graphite black when you were to burn it down. Hydrogens are going to be white. So here is an example of ethane. So there are two carbons with the three hydrogens. Because carbons want to have 4 bonds, I can't add any more hydrogens onto this. I can't take these away. It just wants to be like that. If I was to add an additional, sorry, here's methane, by the way, I kind of skipped it, but this is methane. If I wanted to add the carbon to it, I would have ethane. But if I wanted to turn it into butane and add an additional carbon, I would have to remove one of those hydrogens because carbon cannot have more than 4 bonds. So if I left that hydrogen on there, it would have 5, that's not going to happen. So I removed a hydrogen, I put on the third carbon, looks like that. It's not going to be one straight line. I know in the structural formulas, we'll draw it as a straight line to kind of make it easier on us. But if we're visualizing it in the microscopic way, it's not going to be a straight line. If I want to continue and I want to turn to butane, I'm going to have to take off hydrogen, and now I have butane. So that is that little line like that. I love these things, but they do take a little bit of time to be simple. Any questions on that? Wait. I feel like I'm back in COVID times when I had to do both. Not as easy, but doable. This needs a lot of patience. Okay. All right, let's continue. The 3D model is what I have down there. It kind of is a way of us drawing what I just had on the screen. We're gonna hit VESPER, VSEPR much later towards the end of the semester. But essentially that's just a 3D model of how things look. So thinking microscopically. The dashed and the wedge just tells you if it's coming out at you or going away from you. And then as you get further on into chemistry, we get lazier and lazier, or what I like to say, more and more efficient. Because an efficient chemist that doesn't cut corners is a great chemist. If you cut corners, you're a good chemist. But this is a much quicker way of us writing butane. Instead of me having to write out all those hydrogens, we'll do a line model. So I want you to get comfortable kind of seeing this and thinking, okay, every time you see an end of a line, there's a carbon. And then the hydrogens will fill in place because we already know whatever's left over is going to be hydrogens. Here is a fun part. So I know that I mentioned like my goal is not to be a memorization course, but the more you practice, some things will stick to you a little bit better. So you'll start hearing or me saying methane. I want you to think one when you think meth. I know we all think of something else when we think meth, but methane or meth means one carbon. F is for two. Ethanol, the drink that everyone loves. Ethanol is gonna be 2 carbons. Prop, 3. Bute, 4, 5, pent. We get into ones that are more obvious. I think when we all think of like pent, what am I thinking of? Pentagon, yes, I'm thinking of something not nice. Hex for 6, oct for 8, hept for 7, non for 9, dec for 10. So I want you to get more and more comfortable because I might not always say this is C6H something. I might start saying, here I have an octane. What is that? So I want you to get more comfortable kind of identifying. If I say octane, instantly think there are going to be 8 carbons, but we don't quite know how many hydrogens because it's not always perfect. So there's a little helpful thing, I forget what it's called, but this is what we use a lot to kind of determine how many hydrogens. So the N represents how many carbons. So if I said octane, the N would be an 8. So C8H what? So if it's 2N plus 2, that would be so C8 and then H 2N plus 2. So that would be 16 plus 2, it would be 18. So octane would be C8H18. So I want you to get kind of comfortable with that, being able to say, okay, if I say octane, it's this. I do want to point out that butane, let's do butane real quick. So C4H what? So 2 times 4 is 8 plus 2 would be 10. So butane is C4H10. This is how we can write it out in a formula, a chemical formula. Typically it's short and sweet, where we condense what is the total amount of carbons, what's the total amount of hydrogens. But this is also a formula, and this is also a formula. They're all right. So typically we will use this formula down here, the structural formula, to kind of like help us visualize and draw out what the structure is, but it's still going to be, if you count it up, C4H10. And so I want you to get comfortable recognizing it's all under the same umbrella. It just typically is how I'm going to give it to you. If I ask you to draw it, I couldn't give you just C4H10 and have you draw it, because what happens if some carbons are attached to other carbons? We don't quite know that. So the structural formula is very helpful for identifying what it looks like. But in general, the chemical formula will just be C4H10. And when you get into organic and stuff like that, you might start mixing double and triple bonds, but we're not quite there yet. So for single bonds, you'll have an ANE at the end. So methane only doesn't really have, yeah, it's all single bonds. Ethane, propane, butane. So we're not playing around with the butenes and we're not doing that. So it just ane. So now we're going to open up our in-class activity. If you are online, please get it up and start going through it in your notes. We'll do, I guess we'll do one together and then we'll have some time to work. Maybe if you want to work within groups, if you're in person, online, we'll just work through it. Okay, so why don't you get that up and then I will get my job to begin this step. Does anyone need a copy? The new document, so. Out of focus. Is that better? Yeah, okay. If you are online, I'm just gonna be going over the first one, maybe the first two with you, and then I will give you some downtime to work on your guys. Alright, so on the far left, it tells you the number of carbons. So what are we gonna start with? With one carbon? Methane, because one is meth. So if it says name, you do methane. And then it says formula, so that would be, let me put it up here, put on the top of your sheets, CNH2N+2, that'll be very helpful for us. So if I'm gonna put that formula, I'm gonna do C, and I could put C1, but typically we do not put ones behind it, so I'm just gonna do a C. And then H what? What is 2 times 1 plus 2? 4. Okay, so that's all at once for this first one, name and formula. Then it says Lewis dot structure and structural formula. Lewis dot structure, that's just when I have the carbons and the hydrogens all connected. Don't worry about doing 3D anything, I don't care. It could be just a straightforward one, so that would be a carbon in the middle. And it would be kind of combined with 4 hydrogens. And this one's like kind of an exception because the structural formula and the formula are the exact same thing. But as you start adding more and more carbons to it, it'll be a little bit like you'll start writing them out with carbon by carbon by carbon. So methane's probably the easiest out of all of them. Also with the zigzag structure, there's nothing to zigzag. It's just one carbon. Let's do the next one. If it's 2 carbons, what is it? Methane. So C2H what?
6.
6, yes. All right, so here's what you're gonna start doing, and as you keep adding these carbons on, you're gonna do a carbon connected to a carbon, because that's gonna be the main structure because you have the 2 carbons, and then put a hydrogen around it, but carbon can only have 4 bonds. So one of those bonds is being occupied by a carbon, so I have to only put 3. So if I just double check, each of those carbons are attached to 4 different things. That has 4 bonds. I didn't add anything else. I don't have too little. So let's do the structural formula. First, let's start over here on the left. CH what?
3.
Yes. So even though if it was attached to a hydrogen, it'd be CH4, this one is CH2 because it only has 3 hydrogens attached to it. So CH3, and then what's next?
CH3.
CH3. And then I guess if it was a zigzag structure, it would just look like that because it's just 2 carbons. But as we go further and further on, you'll start to see the zigzag thing. Right. So go ahead and start working through this sheet. There is a back to it that kind of goes over, you know, what are the names. So I'm looking for, like, for instance, one is meth, and so on and so forth. You have your notes. If you want me to put slides back up, I can certainly do that. But we're going to spend the next probably 10-20 minutes working on this. 10 minutes, no, let's do 10-20. And then I'll be here if y'all have any questions. Question at the bottom, there's a question at the very bottom, it's a little tough, but I want you to practice it. Go for another 3 minutes. Does anyone need more time? Let's go over, I kind of did the shorthand version, but I don't like writing out everything always, it gets kind of redundant. So it kind of force you to realize, why do we do shorthand? Because it's kind of exhausting to have to do all those carbons, hydrogens, and lines. So I just kind of skipped this, but if you want to check the key, I have my key here, but Dr. Patterson has a different key online that's very similar. So I kind of skipped the steps, but I did the zigzags. And then here would be the structural formulas. I definitely want to do this last one because this one is kind of newish and a little tricky. It says work backwards. We're going to draw the Lewis dot structure and write the formula. It's not the structural formula, the formula itself. The structural formula would be really hard to do. So first, let's write the formula. How many carbons? So remember that each end of a line is going to have a carbon on it. This right here is I guess a hexagon.
So.
Okay, so yeah, I agree. So there are 6 carbons in that hexagon, and there's another carbon right here. So that'll be C7. Let's do H. How many H's? So this is probably why I kind of shouldn't have done this first. I should have done the actual drawing first. Let's go to the drawing. Because I even was like, I don't know, I have to see the full drawing. So first, let's just write it all out.
Plus the 2 on the end. So 18, right? Because there's 2 on the oxygens.
I'm gonna start with the hexagon, and then I'm gonna put those double bonds. So we have a double bond right here. We have a double bond right here, and we have a double bond right here. oxygen here, we have a hydrogen here. Carbon here. All right. We have to add hydrogens onto that ring because the carbons are missing a bond. Remember, carbons want to be touching 4 bonds, and the double bond counts as 2. So if we focus on this carbon right here, it doesn't need a hydrogen added because it's already touching 4 things. It already has its 4 bonds. But this carbon right here only has 3. So I need to add a hydrogen to it. This carbon only has 3, so I need to add a hydrogen. This carbon, add a hydrogen, this carbon, add a hydrogen. This carbon's good, this carbon's good. Okay, so if I now count up all those hydrogens, I have 1, 2, 3, 4, 5, 6. Do y'all get that? Okay. And then how many oxygen? 3, yes, you're right. So that's like a really good challenge, being able to identify that. The hardest part for me was I need to see the carbons, I need to count the bonds, because whatever is missing, I have to replace it with hydrogen. So these are a really fun challenge. I could definitely give you kind of an example of this and like give you this drawing on a quiz or an exam and say how many carbons, how many hydrogens, how many oxygens. So I can give it to you like that. I wouldn't ask you to name it, we're not there yet. But definitely like tell me how many in each.
I don't know if this is jumping ahead, but for the oxygens, do those need to have like the little dots? Okay.
Yes, we haven't really hit it yet, but yes, those oxygens would need dots. So this one, we have 2 on it because oxygen has a even thing. They typically will have 2 lone pairs. So yeah, that would be completing the Lewis dot.
Okay. I just want to, I guess, make sure.
No, you're absolutely right. Does anyone still need this? Okay, I'm gonna flip it over. Let's do the back real quick. Don't forget, it did ask for these subscripts. So what subscript am I going to put behind C for a general formula? And what about behind E?
Is 2n plus 2.
2n plus 2. Now, I haven't asked you to memorize it, but you definitely want to get more comfortable with it. So eventually, if you need to remember how to do octane or butane, you kind of want to have to remember C and H2n plus 2. But for me, I struggle memorizing, so the best way I do it is like, I just gotta look at it a lot. So while I'm doing my homework, have it with me. While I'm doing my quiz, have it with me. It's kind of like a little cheat sheet, so I would have it with me. So the more I look at it, the more I can recall it. Let's go down. Y'all read out to me what these prefixes are.
Okay.
And. O. E. And. Pets. Pets. Yeah.
Awesome. Yeah. So that would be our first worksheet. I have plenty of these gonna be scattered. I'm gonna try to have them for every section because I'm more of a hands-on person. Like I like to do things in front of me. I don't like to just talk the whole time. So this is a good example. The next worksheet is gonna be a little bit longer because it's gonna have to start incorporating math. But this is a lot of fun. I love doing stuff like this. So we just finished alkanes, so we're done with 1.2, which means that maybe at the end of this class or over the weekend, you can take a look at your 1.2 homework and start trying to answer those questions, all of 1.1, 2. I still want to finish 1.3. We're gonna move on to that. So 4 more minutes and then we'll take a break, so. Oh, sorry, the screen was up here. And the key is, sorry, the screen was up here. It's hard for me to share a doc cam. But I'm gonna come back to sharing my screen for the PowerPoints. so I'm gonna ask everyone right now to get out a calculator, because we will be doing math, and I want to kind of check our math. Let me just go through this just because I'm about to get the doc pan back up. Actually, I'll put the doc pan up. Let me see if I can do it so everyone can see it. Here, doc pan. What I can do. In the form, yeah. So I'm gonna pin this and I'm gonna go to my doc cam because I do have the slides out real quick and I want to go over a few things real quick. Just because I'm just kind of annoyed going back and forth for only 2 slides. We're gonna be doing some practice with a calculator. If you are already exceptional with a calculator, that's awesome. But I know when I was going through this and a lot of our students, when they practice on their own, if they're not doing it with me in the lecture, and everything makes sense, but when they go to do their homework, all of a sudden, none of their math, when they type it into the homework portal, is working. And most of the time it's because calculators have these specific functions and you have to be able to type things out like that. And so this, we're gonna go over dimensional analysis, and for me, the most important is, of course, typing it into calculator to get the right answer. And this is gonna be all about multiplying fractions. So I have it on my screen. Let's see. You can't see. But it's a little bit easier for everyone online to see. Focus. So multiplying fractions, what I have on the board is, I have 1/3 multiplied by 1/2. Oh, perfect, let's take a little break. I'm gonna start working on seeing if I can get the doc cam up. Y'all take a 5-minute break and we'll be back at 12:55. Ah. Yay for online students. Sorry, Logan, I'm sorry, everyone. So let's get back. So if you have your calculator with you and you're ready, just make sure that you're using, and not using a graphing calculator. Definitely because the more you practice on a calculator you're gonna use on the exam, the better you'll do on the exam. I hate it when students come to my exam and borrow one of mine and all of a sudden they don't know how to use it. I'll do my best to help, but let's try to avoid that now. So I might say that this might seem redundant, but being able to type this onto your calculator is going to be so helpful because all we pretty much do is going to be multiplying fractions. So if I have 1/3 times 1/2, sometimes students will try to type it in all at once. And it just doesn't always work out. If I was to then put it in parentheses, because I think parentheses are your friends, there's two ways you can go about doing this in your calculator. So keeping everything together. Oh, I guess that was one of those groups that actually worked, maybe because of the ones. But you want to definitely have those parentheses in place. So you can do 1/3 multiplied by 1/2. Or if you really like this method better, is you can multiply all of the numerators. So remember, numerators are what's going to be on the top of those fractions. So in this case, the ones, and then divide it by everything at the bottom. So those are the two ways to do it. So separately, or everything on the top divided by everything on the bottom. So you don't want to just type it in without those parentheses, because if I start playing around numbers, it'll definitely mess up. So the second way would be multiplying everything on the top divided by everything on the bottom. So that will also get you the right number. Okay. So if you're kind of not getting the right answer when you do the math portion on Achieve, just double check how you type things into your calculators. So parentheses are your friends. So if you come into an issue, it might be because you're missing parentheses. If you can also do things separate. So if you just don't want to use parentheses, you can just do everything on the top, enter, and then divide by the bottom. If you can avoid that, if you like, I prefer getting comfortable with parentheses. Units are going to be important. So let's say I'm asking for you to calculate something for me in grams. Double check and make sure that you're having everything in grams. So if you need to convert something into grams to do that, you might need to do a conversion, and that's when you might need to do some extra math. So just double check what I'm asking and double check your units. And then, yeah. Numerator, let me just do this. I'm sure this is not spelled right, but on the top is numerator, you'll hear me say that. On the bottom is denominator, so we do fractions that way. Okay, let's practice. Go ahead and try to get the answers. What did you get for the first one? Two? I also got two. Just a reminder, you gotta do what's best. There's no real perfect way of doing this. Everyone has a method that they are more comfortable with. So for me, I like to just do exit parentheses and I'll do it the way I kind of wrote it out here. That's just because I'm like that, but if you prefer to use the method I have on the right, they both will give you the right answers. Either multiply everything on the top and then divide it by everything on the bottom, just don't forget those parentheses, or for me, what I would do is I would literally type in 6 divided by 13, close parentheses, times. So just make sure that's how you're getting it, and I got 2 as my answer. If you didn't get 2, 1 definitely could be me, but since we're all getting 2, I guess that would be the right answer. What did you get for the next one? 1 more. I also got 1. So that one kind of shows how we kind of broke up that top and made it all top divided by all bottom. Now this bottom one is exactly what you will be seeing all the time in chemistry. It's the same thing. We incorporate units into everything because units just are necessary to make sure conversions are working. But the numbers are what you're typing into the calculator, not your units. So what did you get for this bottom one?
15.272.
I got 54.27, is that what y'all are saying?
Mhm.
Perfect. Okay, so make sure you also got that. I do want to point out, if I was to put all of this together, I'm gonna be a little extra right now. I have 25 grams of H2O times 1 mole H2O times 16 moles of CO2 times 44 CO2. Those ones are important because it works out with the units. I'm gonna leave it in there. The reason why I'm doing this is I'm gonna kind of show you how things cancel, and this is how we use conversions. Let's look on the top and on the bottom. Is anything unit-wise, not number-wise, unit-wise, are there anything on both?
Grams
Grams of what?
of H2O.
Okay, so grams of H2O are on the top and on the bottom, right? So, okay, let's cancel. What else?
Moles of H2O.
Also H2O,
Moles of CO2.
moles of CO2. And that leaves you 1 unit. And that's how we do conversions, and it's kind of assumed like if you have it on the top and the bottom of a fraction, they kind of cancel out and you left 1. So that's what we're doing here is we're kind of canceling out anything on the top and the bottom of that fraction, and the only unit left over is going to be grams of CO2. And the way that you'd want to write this, especially if this was a shorthand question in a quiz or on the exam, I don't know what the exams are going to be like just yet, but you want to include those units. So don't just do blind numbers. If it is shorthand, so you don't just want to just type in the numbers. This is going to be helping us like figure out are the conversions working, is it set up right? So 54.27 grams of CO2. You'll be seeing me do this a lot, so that's just where it's coming from. I'm going to switch back now to the PowerPoint. I might come back to this if we need it. Let's see if I can get it up. I hope that was helpful. We'll be doing this a lot for this section. So dimensional analysis. Oh, sorry guys. So dimensional analysis, and I mean it, we use it all the time. If you come up to, if you're taking a bunch of chemistries and you see me in analytical chemistry or quantitative analysis, I still use dimensional analysis and literally everything. So it's very important. This is probably why I'm gonna be very annoying with how much I'm like going to be over and over again, because this this is where students who don't have that fundamental background, they hit me in Gen Chem 1 or Gen Chem 2, and they're just so overwhelmed. So we're gonna keep hitting on it, because this is honestly the basis of. I'm sorry, I'm annoying. So it's one of the most useful problem-solving skills in chemistry, being able to cancel out units, being able to type things into your calculator. So it's based on multiplying what you are given by fractions called conversion factors. So you probably already have dealt with a lot of conversion factors. I know with me, my husband's not from America and he does not like how Americans don't use metric. He hates it. So I have to literally do all these conversions in my head because he does everything in Celsius and kilograms and kilometers. He's gotten better with kilometers because in America you drive in miles. But in my head, I am constantly having to do these conversions. So he's measuring something in kilograms. I'm like, okay, 1 pound is 2.4 kilograms. So I do that multiplication. It's always. So you've already been dealing with conversion factors probably your whole adult life, and probably younger than that too. So you've already dealt with it. And so we're just going to be going into a little bit more chemistry type conversion factors. So multiplying, I do want to point out the ones are going to be very, very important, especially where they go. And so I don't want you to skip those ones just because you're not actually going to type them into your calculator. They are relevant, especially if you are doing setups, like if I do worksheets with you, or if you do exams that are short answer, you really want to get comfortable not skipping on those ones. Yeah, so you're gonna start seeing me use equivalents, and that's when we start comparing things to one another. And I've already showed you this in the very, very first paragraph, so I'll just go on it over and over today. So creating equivalents, it's based on different ways of describing the same thing. So let's talk about methane. Or not methane. C1H4. When I start talking about equivalents, I'm talking about if I'm comparing one thing, one molecule of methane. Dr. Patterson, if you look at her keys, she uses capital M, capital C for molecule. So I'll just kind of write that down here. If I have one molecule of CH4, how many carbons are in that one molecule?
One.
So for every one molecule of CH4, I have one atom of carbon. How many atoms of hydrogen? 4. So even if I just said CH4, we were able to form equivalents based on that formula. So part-to-part ratios, it would be going from carbon to hydrogen. So we can definitely go carbon to hydrogen. If I was to say, I have 10 carbons, how many hydrogens are in there? So you can use those equivalents to kind of use multiplication and go from carbon to hydrogen. That's going part to part. If I'm going from part to whole, that's saying, okay, I have 2 methane molecules. How many hydrogen are in 2 methane molecules? So we're still able to make those equivalents based on that function. So many chemical calculations require us to create those equivalents, even if it's not given to you. So that's why I mentioned it last class. This is me being able to use my fundamental knowledge to kind of break this puzzle, answer that question, even if I haven't seen it in 10 years. Even if I have no clue what's going on, those fundamentals will help you answer those questions, or at least get you almost all of the way there. This is a skill to develop. It's not something you can memorize. Every semester, sometimes students will just try to memorize, and that's not our goal here. If memorization is just going to go the second the semester ends, it's going to gone. And then when you hit Gen Chem 1, what was the purpose of taking this class? So that's why repetition is going to be quite redundant at times, but it's going to be very helpful. So let's practice what I'm preaching. This is the molecule we did on Wednesday. Write all of the equivalents possible for one molecule of glucose, which is a type of sugar. We have glucose and sucrose. So we'll kind of repeat what we did for methane. I'm going to use capital M, capital C for molecule. So if I have one molecule of C6H12O6, how many atoms of carbon?
6.
Perfect. How many atoms of hydrogen?
4.
how many atoms of oxygen?
6.
Sorry, I ran out of room, so I just keep putting an equal sign underneath it, but I was trying to read one giant line. So that will be, and on the practice sheet that we have today, you will be asked to write out those equivalents. And that's exactly how you get started. Start by writing out what, one molecule of whatever substance, because I might not be nice. I might say, I have butanol. You have to write it out. You have to figure out what it is. So then you'd say one molecule and then write out your C's and your H's, and then you'll break it down like we did here. But sometimes I might give it to you like we have up here. So that's how you would break it up into its equivalents. Any questions on that? Now, y'all go ahead. Write all of the equivalents for one molecule of acetaminophen. The common pain reliever found in title. C8H9NO2. Really small for this. If I have one molecule of acetaminophen, how many atoms?
8.
Sorry. What about hydrogen?
9.
Nitrogen,
1.
oxygen.
2.
So now, if I was to start adding numbers and then saying, okay, I have 25 atoms of nitrogen. How many molecules do I have? So we're gonna start playing around and trying to use dimensional analysis to answer those questions. But the first step is going to be breaking it apart into its equivalents. Eventually, you'll do it in your head. Eventually, you'll be able to look at it and say, you're probably already doing it now, some of you, but eventually, the goal would be for you to look at this and say instantly, I can go between them just by looking at them all. The pro tips, don't memorize the compounds, don't memorize the equivalents, because that's not going to help you in the long run. It's about being able to apply, okay, I give you something, how do we answer it? So every compound is unique, it is a wasted effort to try to memorize, it's these equivalents and conversion factors for everything. Some things, yes, we have to memorize. For instance, if I'm going from kilograms to grams, that conversion is instant. Okay, I have 1,000 grams in a kilogram, memorized, done. But this is not something I would ever ask you to memorize. So the more we use it, the more it comes to us when we do it. Instead, use those subscripts to create the equivalents as you will need them. And then units. I don't want you to start doing like, 1 MC equals 8 equals 9. Like, I don't want you starting to just write out bare numbers, bare naked numbers, because even though today you get that, you of Monday might have no clue what's going on. I know if I look back at my notes, I don't want to say how long ago, Gen Chem 1 all the way to 2000. I can kick myself because I'm like, I have no clue what you're doing. because you just had 5 times 10. I don't know what these numbers meant, like, where did they go from? So do this for future you, do this for you studying, write those units, because you're gonna understand what's everything's going on much better, so don't forget to write out those units. I know when you're doing something fast, like if I'm the first quiz or exam, you can go faster on your calculator, that's fine. But if it's anything that's studying, homework, take your sweet time, write out those units, because you're doing this for future you. It took me a long time to start doing that, because I think I just kicked myself past me, I'm just so mad at. Alright, let's keep practicing. Now let's get into how we're going to do a dimensional analysis. If I have a sample of glucose that contains 48 atoms of hydrogen, how many atoms of carbon are in the sample? How many oxygen? How many molecules? So we're gonna start getting into word problems. And I know I have very high test anxiety. I don't know if it's obvious to y'all yet. I have very high anxiety in general. And I sometimes panic when someone gives me a paragraph. I just do. I'm like, I have no clue what's going on. But it's just taken me a lot of practice to start recognizing what's going on. What do I have and what are they asking? And so Dr. Patterson put given and wanted here because I'm gonna go through this problem and I'm gonna highlight what are they giving us? What are we starting with? And then what are they asking for? So let's go first and tell me. What is given? 48 atoms of hydrogen. So that's gonna be what we start with because that's given. We don't start with what we don't have yet because we can't start without any, I get to start with something. And then what are we wanting to find?
Atoms of carbon.
So atoms of carbon, and then atoms of oxygen, and then molecule. So it's a 3-part question, but let's start by figuring out how many carbons. And this is when you definitely wanna make sure you write out your units. So I'm gonna write everything out, you write everything out. So always start with what we're giving. So I'm given. Oh gosh, sorry. 48 atoms of hydrogen. So just gotta double check. It's asking for carbon. So if I go back to that slide, we already did all the equivalents. But if you haven't done that yet and you really need to do those equivalents, always start there. Write out until you're more comfortable recognizing and looking, always write out those equivalents. But tell me right now, how many in, I'm just asking for the number, the subscript right now, but how many carbon atoms are in one molecule?
Well, wait,
Carbon.
sorry.
Because you got, that's the next question is hydrogen. So carbon was 6, hydrogen is 12. So if I do have those equivalents, for every 6 atoms of carbon, I have 12 atoms, this is that part of that equivalence of hydrogen, right? So I'm gonna start there. On the numerator side, I wanna put what I want. On the denominator, what I'm trying to get rid of. So usually it's your given. So I want 12, no, wrong one, 6. So remember, if I have something on the top and on the bottom, so I'll put a 1 right here just to kind of show you. If it's on the top and the bottom of that fraction, you can cancel it out. So I will cancel out atoms of hydrogen because they're on the top and the bottom, they cancel out to be 1, which leaves my overall answer to be atoms of carbon. So the way that I would type this into my calculator is 1, you could do 48 times 6 and then divide by 12. Or what I do is I do 48 times, open parentheses, 6 divided by 12. Same thing. So when I did that, I can't do this in my head, so it's 48 times 4. When I'm challenged, I can make it work, but I just always, like, I would type it in my calculator because I don't trust myself. 24 atoms of carbon. So double check, make sure that you read the full question, because if this was a short answer on the exam, you'd be missing oxygen and molecules, and you already did all the hard work, so let's just finish the hard work. I'm always gonna start with my given. So if I have 48 atoms of hydrogen, always start off with that. And then it asks for oxygen. How many atoms of oxygen are in this molecule?
6.
6. Nope. I always catch my mistakes, but that's why it's like, it's okay to make mistakes, and the more you get more comfortable, you'll start catching your mistakes, and that's awesome. Because that's all I do, is just catch my own mistakes. So it's the same exact math as above, so I'll get the same number, but it's always going to be important writing it out to make sure, okay, does that make sense? So 24 atoms of oxygen, so my atoms of hydrogen cancel out. And if I have 48 atoms of hydrogen, I can now have 24 atoms of carbon and 24 atoms of. The last one, I'm just gonna copy paste, but we're gonna do molecules. So does anyone still need these notes on the board? I'm gonna erase them. So I'll start my given again, 48 atoms of hydrogen. Let's go back to the equivalents. I have 1 molecule of glucose for every 12 molecules of hydrogen. So in the numerator, I'm going to put 1 molecule of glucose. And I'm gonna put 12 atoms of hydrogen. So that was that equivalence. We wrote it all out. 1 of this equals this, then this, then this. So 1 molecule for every 12 atoms of hydrogen. So I'm just gonna take 48 divided by 12 and I get 4 molecules of glucose. So that's how we went from part to part and part to whole. Does everyone understand where I got the 1 from? Don't ever hesitate to ask. I want to make sure we're all on the same page. Anything about that? We're doing a lot of practice, very similar to this. And this is, I guess, just taking what I just did. Great. So yeah, always start with your given unit and chemical. Always include those units in, because you want to make sure the units cancel. Conversion factors, those equivalents that we developed and we made. So go back to how many this is there, how many this is there. And then of course, type it into your calculator to get the overall answer. Okay. Now you go. So this one says, how many atoms of hydrogen are in a sample of acetaminophen that contains 24 atoms of carbon? And you'll do the same process. Find how many atoms of carbon, how many atoms of nitrogen, oxygen, and molecules. So our given, I'll highlight the given, is, that's not it. 24 atoms of carbon. So that's our given. That's where you start from. And then we're looking for, I'll highlight in orange, atoms of hydrogen, atoms of nitrogen, oxygen, and molecules. Does everyone have this yet? Does anyone need this? No, okay. How many atoms of hydrogen were you able to calculate? 27. I also got 27. What about nitrogen? Oxygen?
Six.
And then molecules. I got 3. Did y'all get 3? Alright, so the rest of the practice problems actually overlap with the problems that are on the worksheet. So right now, I'm just going to switch to now us working on the worksheet. But before I get there, while I just got the email, because we were locked out, they made a complaint and they moved us to Chem 133. So if you were with us the first day, that was the same classroom. If you were not here on Wednesday, the way that you get to Chem 133 is if you were to exit this way and go up the stairwell, it's the first classroom on the first floor. Okay, I'm sorry about that. I prefer 133. I felt like it was much better. I absolutely hate this. So I'm excited about that. We're gonna be much closer, but I'm just so sorry that the semester's gone off so bad. But okay, so right now we're going to switch over to that worksheet and we're gonna work on that the rest of class. If you finish early or you leave early, you're welcome to. But if you wanna work on it, if you need to just get extra practice, please stay, we'll work on it. And the key is online, so if you do have an out, you have access. For the online, I'm going to stop recording just because we're gonna work on a worksheet and I don't think we can have 10 minutes of not teaching, but I'm still gonna be on the